Okay, if we're done with explosive atmosphere, we'll move on to method 514, a little bit of vibe. All right. All right. So in order to use 514, you need a lot of information. There's 4 test categories. There's 25 categories, 4 test methods. More than likely, you're going to be running 1 or 2 or 3 of different methods. You got transportation vibe, what a vehicle you're on, and all this. So you got to do a lot of research and to figure out what curve and how you're going to run. Now, if the DoD is nice to you, they'll tell you, right, and make it nice and easy on the contract. But if you're going after a contract and you're not sure, then you got to work yourself through some checklists, and we're actually going to do that today. All right. So we need to know, how it was shipped, how it's stored, how it's deployed, how it will operate during the test. How many items do you need to be supplied? How long do you want to take? More than one procedure test category usually does apply. All right. But there is a way we can combine curves and cut down on your test cost and test time. And we'll go through that a little bit as well. All right. So this is what we need to know. So the first thing is we need to know how your product's going to get from where you make it out to the field. All right. So you're going to have to go through, is it going to go by truck, train, aircraft, helicopter, boat, whatever you need to do, So since we're doing vibe, so in handling, you got road, you got rail, you got in-flight. You can see, if you're not sure, you need to define that. If you're really not sure, you can go through all of these, figure out what your curves is, and do the worst case. Worst case is allowed. So you can combine them all together and do something, but you definitely need to know your life cycle. All right. So, and this is only to get you into the field. All right. And then once you're in the field, you need to know if it's man carried, if it's on a tracked vehicle, if it's on a ship, aircraft, helicopter, sub, missile, gun. Because now you have a whole new. So we got your unit from where you manufacture it over to the theater of operation. Once you got to the theater of operation, it has to get out to the theater. And then once it's out in the theater, how do we use it in the theater? All right. So all of these cycles need to be figured out, and how you're going to do it, and how you're going to do it. And MIL Standard 810 sort of tries to help you. There's these checks. So MIL Standard 810 is broken into 3 parts. There's part 1, which is the front part, which is where this is from. Part 2 is all the testing. Part 3 is all the climate. So once you know what theater you're in, you can go to part 3 and figure out what test temperatures you're going to do. Cold, ultra cold, tropical, whatever it is. So if you're doing vibration by a wheeled vehicle, tracked vehicle, the speed, how long it's going to be there, if it's operating, details. All these curves in MIL Standard 810 are time compressed, but they do tell you, if you run this curve for 1 hour, it's 500 kilometers, right? So you can figure out how long you need to run the by how long it's going to be on each vehicle. All right. So you go through, you figure all this out. You can do the same with shock. I actually didn't do it with shock, but it's another one. So once you figure out how it's getting there, and this is for transportation. And then you got tracked vehicle, the distance, the average speed, the max speed. Is it secured? How long? So you actually need to sit back. I'm sure you probably did it during your design phase on how you're going to use this unit, how you're going to get it there. So as you do this, just write it all down. Fill it all out, and from here we can figure out what curves you need to run. So once you get it all done and filled out, so this is fun. So you got the amphibious vehicles, you got tracked vehicles. You got rotary wing, fixed wing, so helicopter or fixed wing aircraft. is it mounted? Is it not mounted? Is it staying in the aircraft? Is it secured cargo? Is it not secured cargo? All the way through. Fixed wing the same way. Duration, stores. So, and then shipboard. So in MIL standard 810, we're not talking about it, but we'll give it a quick second. Method 528 is shipboard vibration. It's actually a rewrite of MIL standard 167. The Navy doesn't like you to reference MIL standard 810 method 528, even though it's exactly the same. They like to see MIL standard 167-1. So when I talk shipboard, just remember it should be 167-1, not method 528. So the DoD actually took the Navy spec, dropped it into a section, added a section in the 810, and the Navy still's like, yeah. So they're kind of old school. So just remember that, that's all. But you can do shipboard, obviously. Handling, drop, is it going to be man carried? Is it going to be slung underneath the helicopter? However else, can it be dropped? Is it two-man carry? All of this you're going to have to figure out. And the purpose, obviously, for this 810 is to provide guidelines for defining vibration environment. Materials can be exposed to it throughout its life cycle. A lot of customers will go through one unit, so it gets kind of beat up pretty quick. If you're doing transportation vibe, make sure you have some extra boxes. We're allowed to flip out some boxes. So just have extra packaging material with you. The units do get beat up pretty bad if you're running through all the tests. So not sure what the cost is of the unit, but you're allowed to change units, fix units, do everything you want. Every test is a standalone test. So you can run transportation vibe, and then take a new unit and run op vibe, and you take a new unit. So you're allowed to do that. There's no accumulation of tests. So you can high temp, low temp, humidity, all can be all separate. You can have 28 separate units if you want. There's 28 methods, and I wouldn't suggest doing that because I'm sure your investors would not like that, but it should be fine. Yep. So every test is a standalone test inside MIL standard 810. Application used for all types of material and tests, including ESS. So they tell you can use it for ESS for screening tests, but they don't give you any direction. All right. There is a spec out there called NavMat, which is a Navy screening test that has a 6 GRMet test in there for 10 minutes in the worst case axis. That'll be my suggestion. But 810 says you can use it for screening, but then gives you no directions and no curves on how to do that test. So you'll see that as we go through the presentation. Combined environment, use the method for the vibration portion of the test and other methods. So if your unit's on a shock mount and it's going to Alaska, we should run it at ambient and cold because obviously your shock mounts are going to change your residence and things like that. So some thought needs to be put in there. 810 doesn't say you have to do it, but just in case, so some thought. Most of the time, vibration 810's running at ambient because you have your standalone temperature test and your standalone test. But if you're shock mounted, it might be something you want to think about because your shock mounts are going to change based on temperature. And so you can run method 501, method 502, which is low temp, high temp, and 507 in altitude. You can actually run it all together if you wanted to, but I wouldn't suggest you do that. But we have run high, low temp, humidity, altitude, vibe all at one time, a couple of times. So yeah, if you want to, you don't save any time. But all right, some of the limitations. So there's a lot of specs out there when it comes to munitions. 810 does not cover those specs. So if you have munitions that grenades or whatever, maybe they all fall under a different spec. So we don't do anything to do with munitions in the 810. So safety can be used to coordinate platform and material interaction. So 810, we assume that the place your unit's being mounted is rigid. We have to assume it's rigid. So we don't do the interaction. So if you're on a vehicle that's on a plate that has a resonance and your unit mounts, you're going to have to go in and get that data. We don't try to simulate that. We assume you're rigid, okay? And 810 uses what's called Gaussian distribution. So if you're on a system that's responding and your unit responds to that system, you might not have Gaussian distribution of your random either. So that's when you get into this ketosis stuff, which we're not going to cover today. But so you just be aware of that. So we assume everything's rigid. Our fixture is more rigid than the system it's going to be mounted on. We don't try to not introduce any resonances. So, like I said, there's no guidance on ESS exposure. It tells you it can be used for it, but they don't give you any guidance. And use the method, another method to account for environmental synergies. So we talked about that. It doesn't really account for it, but you can combine the tests together depending on what the contract requires or what you think you require. We can combine the environments together as needed. So, but it's not part of MIL standard 810. So we're limited to a single degree of freedom. We run X, we rotate a unit, we run Y, we rotate it, we run Z. There is a triaxial test in 525 if you want to run triax, so that go out to 2,000 hertz. But it hasn't really caught off in the industry. I don't even think we've been asked for it. The problem is you start getting these forces at different angles that can cause some failures that you're not used to, because you're getting vibration all three directions. So, but there is, if you wanted to do triaxial, you can use method 525. So, not in method 514. Method 527 is MIMO, again triaxial. So, again a different method. So, 527 is 525 is we talked about if you have a system that's going on a system that's responding and you take an accelerometer, you have to get that curve. We can go in and take that response and turn it into a drive wave on our shaker. So that's a waveform replication, that's 525. If the default curves provided within the various categories are used in reference curves and multiple axes, it should be recognized that the cross-spectral density terms will be undefined. So when you run a triaxial test, there's a measurement called coherence, where we want to make sure that the vibration in the X, and the vibration in the Y, and the vibration in Z are not in phase. Because if everything's in phase, it's not an independent triax. So then you get a coherence of 1. So it's not defined in 514, but some of the other specs define it as being less than 0.3. And I think maybe 527 does the same thing. So there's no definition. If you're using the vibration curves out of 514, what it's saying is more than likely you're not going to hit the coherence number that you need to hit, because all the drives are going to be basically the same. But if you use some phase shifting, all of that, you can get the coherence down. There's a few things you can do. So all these 25 categories fall into one of these 4 test methods. All right. So no matter what curve you're running, random, sine on randoms, random on random, all falls into one of these 2 categories, 4 categories. Actually, I say 2 because, this one is for 1 and this one's for 1. So it's either in 1 or 4. So, but 2 and 3 we do have methods for it. All right. So our first one is a general category. This probably 20 of the 25 methods fall under general vibe. Loose cargo, a lot of people call it a bounce test. So ISTA, ASTM, MIL standard 810. The only difference between this one and commercial carriers is 810 you have to bounce on a metal plate. The other ones want wood. 810 only allows synchronous, doesn't allow linear. The other ones do. This one is taking your tank or whatever it is, tying it down to the back of a truck and driving it around. And then procedure 4, this is for things below the aircraft or inside bomb bays. When you open the doors, you get acoustic resonances and all of that. This one we have curves for. This one we have curves for. This one is a road course. This one we need data. There's nothing in A10. They tell you sort of how to run it, but we have no curves. We got to do a lot of math. We can get some curves, but it's pretty much method 525. So go out and grab your own data. Here's a breakdown. So we got, like we mentioned, we got shipping, handling, ESS, the manufacturing process. Do you do house call testing? Do you do a screening test? There's no direction in A10. There's no test procedure. So you're on your own up here. A lot of people do. You're familiar with house call testing, 6 degree of freedom stuff. Shipping, handling. You can use ISTA. You can use ASTM. Some of the commercial specs. Then we get into the transportation inside A10. You can see we got either test category 1, 2, and 3. So we got secured cargo, loose cargo, large transport. You can see this. I think these are the only 2 that use 2 and 3. And then we got transport in the aircraft. So all of these are the test categories. You can say they add up pretty quick, but they all go back to the same method. So and then we have the operational tests. You got aircraft, aircraft stores, missiles, ground, watercraft, engines, personnel. Supplemental, again, external, we have no direction. So you can go through and decide, once you know your life cycle, and you know how you're transporting it, how it's operating, where it's going to operate, how it's going to operate. You can go through and find your category, and then you can find your test method. All right, so A10 allows you to do a couple of different control strategies. So when you run vibration, the control accelerometer, where it's mounted, is the only place on that table we know exactly what's happening. Because, aluminum is like an ocean, right? Frequencies travel differently through the water, right? So here we like multi-point controls. There's a couple of reasons why. So A10 allows you to do a single point, which is fine. But 99 out of 100 times we'll do multi-point. We like to use cross corners. First of all, it's safety. If our control cable goes bad or our control accelerometer falls off, due to the feedback loop on our controllers, it will run to max level and then kick off. If we have a second control on there, it will stop the runaway until it realizes we have a control signal loss and then shut it down. So it stops runaways on the tables. It gives you a better test. We usually do cross corners, so we can get an average across it. So we'll do straight out averaging. So this is 50%, this is 50%, and we combine together, and then obviously we get one curve. A10 does allow you to do max, min. You can do force limiting, acceleration limiting. A10 allows all of this, but maximum means you never exceed the curve, so you're under testing. Minimum means you're over testing because both accelerometers are always above the curve, right? So it looks at them individual. So there's some other specifications as well. So random vibration, all frequencies are present all the time. The only thing that's random about random is the peak acceleration level, the distribution, all right? So all frequencies all present all the time. So there's another degree of freedom we use is with the statistical degrees of freedom. So since random's always changing, always out there, we never know within 100% certainty what the table's doing, all right? So if you're at 120 degrees of freedom, we're 94% sure what the table's doing, right? So pretty good accuracy. The higher you bring the degrees of freedom, the more accuracy you get, but now you're throwing away loop time. It takes longer, you need some more loops. So 120 seems to be the perfect mixture. But yeah, so that's what degrees of freedom is. Let's know the accuracy of our random vibration. It's a sort of paraphrase. All right. Composite controls, maximum. plus or minus 3 dB below 500 hertz. The rigid frequencies where most of your fundamental frequencies are, your rigid modes, below 500 hertz, some are a little bit higher. We hold plus or minus 3 dB. Random is power, power spectral density. So minus 3 dB is half power for you electrical guys, right? So same thing. If we use sine, it's minus 6 dB. It's plus or minus, it's 10 log to 20 log, right? So above 500 hertz, we can deviate plus or minus 6 dB. All right. So you can have the damaging potential energy of a random vibe or anything is the area under the curve, the area under the shock, the area under the peak. So at the higher frequencies, it's a very small area. So the damaging potential is less likely. And so they allow you to deviate. Frequency sweep rate, 10%. So sine, we sweep it 1 octave a minute, 2 octave a minute. Sweep rate has to be within 10% of the stated. So these are just standard tolerances. All right, frequency. Within 0.1% of the tolerances, cross-axis. So we run X, Y, and Z. All right. If your CG is off-center, or you have a high CG, slip tables, or whatever it may be, we'll create motion in the other axes. All right. So if you have a high CG, or your CG is off-center and all of this, we will monitor the cross-axis. So the cross-axis has to stay below the input up to a certain frequency. All right. Test duration, plus or minus 5% of the stated. Duration of unfiltered. All right. So lab equipment failure. So we're running along. Your test is running along. We have a shaker problem, whatever it is. Stuff happens, right? So if we have a lab equipment failure, like I mentioned, if you use one control accelerometer and the accel falls off, the table runs away, you end up in an over-test condition, right? Well, if the unit still operates fine, we can continue to test. If you don't like the over-test condition or something happens, obviously we'd have to start over again. You're not allowed to replace parts in a unit that's undergoing testing. You got to do X, Y, and Z all at the same time, all right? You can't do X and then replace parts and then do Y. So if we're in the second axis and we have a problem with our equipment and we end up your unit ends up having a problem, then we'll have to start over again. All right. So it's unfortunate. This doesn't happen a lot, but test item issue, preferable option is to replace the unit with a new one and start all over again. But you can replace and repair, but then you got to start from scratch. All right, so it's up to you which route you take. So no repairs during testing between axes. Can you tighten bolts? It's debatable, right? If you want to tighten bolts, then yeah, we'll obviously note it. But theoretically, you're not supposed to touch the unit in between the axes and do all three together. All right.